hello.
Hello.
Hi, nice meeting you.
Hey, nice to meet you. Can you hear me?
Yes, I can definitely hear you.
Yes, okay.
Awesome. You're early. That's good.
Yeah.
Hello,
Thank you for
Eric.
joining us.
Hello. Hi.
You are from the NATO, right?
Yes.
Good to see you. Good to see you. I saw a lot of emails already from you, so
Yeah.
now we can see each other in person. Okay,
Yeah,
okay,
yeah.
good.
Always good.
Yeah, you had a lot of communication with my colleague Caroline already, yeah?
Yes.
Yeah. All right, very good. Yeah, so last week I was in Luxembourg, but unfortunately I
Good afternoon. I'm hearing some strange
to visit you.
noises.
Yeah, I don't know if it's my connection or.
Hi, Eric.
Hello.
Nice to see you.
Hey, nice. Thank you.
I'll turn on my camera as well.
Yeah.
And there we have our presenter.
Yeah. Hello, Prakriti.
Hello, everyone.
Hello.
Hi, Pakruti.
Hello. Good to see you.
We're waiting for a few people.
Is everything all right?
It's really hot today.
It is, yeah.
Uh,
Prakruti, for you it's still early morning, right?
Yeah, it's not too bad. It's 9:30 here, so
9:30.
Yeah.
Okay.
yeah,
That's okay.
yeah.
So in total we expect around 7 or 8, Tara?
Yes, yes.
Yeah, we should wait a few more
waiting for
minutes.
8 in total at this moment.
Yeah.
Yeah, it's not 30 yet, it's 27.
Hello, Oscar.
Hello, hi Eric. Sorry,
hello. Hi.
Hi.
I couldn't set up a cam, so I'm in the office. Sorry about that.
It's
okay.
okay.
Yeah, thank you.
It's good that you're here.
Thanks. So are we expecting someone else or?
Yeah,
We're expecting at 8
Yeah.
people in total.
All right. Okay, cool.
Yeah, a few more minutes.
Yeah, okay.
Oh, hello, Donia.
Hello, everyone.
Hello.
Hi. Thank you for joining, yeah?
Thank you for invitation.
Tara, we are waiting for, I think, Amplion, in the Netherlands.
Yeah.
Yeah.
Aurelio.
Yeah.
And
I can,
Animax and VSL.
And VSL as well. Okay, yeah.
I can call Aurelio.
We have 1 more minute. There he is, Aurelio. Good afternoon, Aurelio. You're muted. Yeah.
Yeah, good afternoon, everyone.
Hello.
Good
Hi,
afternoon.
Aurelio. Hi, good
Good that you're
afternoon.
here.
Hello.
So we are waiting for 2 more people.
Hi, Alexandra.
Hello, good afternoon.
Good afternoon.
Hello.
We are waiting for 2 more guests. From
I think
VSL and Animax.
we can already start and then maybe they come in later.
Yeah.
Yeah, we should, yeah, we can start. So thank you very much, everyone.
Sorry, Erik.
From
I'm
the
not sure if it's only you, but I can.
Today we.
Erik, your connection is not
Yeah, it's
good.
freezing. Yeah, sorry.
you hear me?
Not that
Up,
well.
on and off.
Yeah, I'm sorry. The whole day I had some internet problems.
Maybe you can go out of the meeting, Erik, and then come back. Maybe that might be better.
It's the
I
temperature,
will
I guess.
switch off my camera. Maybe it's better. I propose that start.
Yeah. Let's see what happens.
I thought it was my connection at the beginning, but
No, it's definitely
It was
Erik's.
Erik's.
Yeah.
Good afternoon, Raoul. Welcome.
Hello.
Thanks for joining.
Hi,
hello.
good afternoon.
We're waiting for Erik to join. He had some computer problems. Otherwise, Tara, I'm not sure if Erik, maybe he can do a little speech at the end. You just start.
Yeah. All right. So my name is Tara Gabriel, marketing worker of EcoBFI. And first of all, I want to thank everyone for joining on this webinar. We will record this webinar as well. So later on, you will receive all the ins and outs through email. And we will also send you the presentation. I would kindly ask you to save your questions until after the webinar itself. But you can already put it in a chat, so you know in the moment what your question was. So that's it. We'll just wait for Erik, and then we can start off with Pratruki. Caroline, we cannot hear you. You're muted.
Sorry. Prakuti, maybe you can just start and Erik will come back. Otherwise, it will be for maybe too long for some people.
Okay, sounds good. All right. Hello, everyone. If you've not met me, I'm Prakriti Prasanna. I'm an applications engineer here at Copper Mountain Technologies. So let me go ahead and share my presentation and then I can start talking. All right. So is everyone able to see the screen?
Yes.
All right, great. So I'll just right now just explain what I have here and then dive into the presentation. So anyone who's not taken a look at what the BFX looks like from us, this is that system. It's very, very compact. Unlike a regular VNA where you're used to seeing ports in the front, these are on the sides of this guy here. It's pretty useful when you're especially connecting it to frequency extenders instead of having to work with cables coming out from here and having to squeeze it. It's really convenient to have it connected on the side. So, and I have these extenders from Eravant, and these are 50 to 75 gigahertz. And I just simply have a WR15 filter connected between these two ports. I do want to mention that I have the system fully calibrated. It's a full two-port calibration that I performed using this CalKit. And yeah, so I'll just get started, and everything with the extender and the BFX connection-wise remains just as it's same as how you would be connecting a regular VNA. So you basically have the LO and RF signal coming into the extenders to drive these, and then you have the IF signals going back into the BFX, which gets down converted, and then that's how just like how the regular VNA is connected, connection-wise, and everything is just as it is. And then now I'm going to start talking about what I have in the presentation. And like Tara mentioned, if you have any questions, do leave it on the chat as I go along. And then in the end, we can definitely discuss all those questions. So today I'm very excited to introduce this new approach of millimeter wave measurement systems. And today we're going to be talking about the BFX, which is basically the frequency extension based system that is primarily designed for millimeter wave measurement. What makes this especially exciting is that it's not just another variant of a traditional VNA architecture. Now, what you're looking at here is a patent pending architecture from Copper Mountain Technologies. Like I mentioned, it's specifically designed for millimeter wave S parameter measurements. And the BFX is compatible with all the leading frequency extenders that are out there in the market, while dramatically reducing the cost and complexity. So traditionally, as we know, achieving a millimeter wave measurement has required us to dedicate a full VNA when you connect the frequency extender system to it. But when we started looking at how those systems actually work when you have a frequency extender connected to your VNA, we realized one important thing, that majority or most of the internal hardware is not really used when you have the frequency extenders connected to it. So this observation basically became the foundation for the BFX. Now let's take a look at the core problem as to what the issue is with the traditional approach and why you need a BFX instead of a traditional VNA. So in most labs, when you have a VNA connected to the frequency extenders to make your frequency extension measurements or millimeter wave measurements, that VNA is usually permanently tied to those extenders. And at that point, the VNA is no longer acting as a standalone measurement system. So its role becomes much narrower. So it's basically acting as an RF source, LO source, and IF data acquisition system. And then what happens is with your traditional VNA approach, most of the sophisticated internal hardware that contributes significantly to the cost of the VNA remains unused when you're using frequency extender system. So what the BFX does here is it removes all the unwanted components. And here, as we've shown in the block diagram here, all the components that are unused, especially when you have the frequency extender system, is highlighted in green color. Although this might not look like a lot of components, these very easily add up to the cost because most of these components are broadband coverage. So they can very easily add up to the cost of the VNA. So you're basically paying for capabilities that you're not even using in a traditional approach. So that is the core problem here. Now let's talk about the BFX architecture. Conventional VNAs includes a substantial amount of internal hardware that remains unused, like I mentioned, when you have the frequency extenders connected, and these include broadband low frequency coverage, internal directional bridges, reflectometry hardware, and standalone measurement capability. Of course, these are very, very valuable in a traditional VNA workflow. But when you're using your VNA, especially in a millimeter wave environment, these are often bypassed. So you basically don't need these components to be a part of your VNA when you're using it to drive your extenders. So in this block diagram here, compared to the previous one, we've removed all those components that remain unused, especially when you're using your frequency extenders. So this, of course, the result is reduced cost and complexity of the setup. Now let's talk about some of the advantages of the BFX architecture. So higher RF and LO power. This is one of the most important technical advantages of using a BFX. What happens in a traditional VNA approach is most of the power is lost through your internal directional bridges and other front-end circuitry, even before the power reaches the extender system. So since the BFX removes these unused components that are not required, it is driving the extenders much more directly, which results in higher RF and LO power. And this becomes especially important in applications that require longer cable runs, data separation between extender heads, such as antenna testing. So you have more room for robust applications or measurements because you have higher power to deal with, up to 16 dBm, if anyone's wondering what that power level is. Previously, our copols could only go up to 6 for the LO output, and RF was 10 dBm. So now with this, you were able to go as high as 16 dBm. So the next advantage is you're able to recover your valuable lab resources. So this is one of the most impactful operational advantages of using a VFX. So without a VFX, what's happening is you're using your very expensive VNA simply to just drive your extenders, and you only have one station there. Now, but with a VFX, since it's significantly more cost effective compared to a traditional full VNA, you have the opportunity to have a system that can permanently remain connected to your frequency extenders, and you don't have to go back and forth between having your extenders connected versus using the VNA to do other measurements. So with a VFX, since its primary job is only to act as a frequency extender driver, you can always leave your frequency extenders connected to it while you can return your other VNA to make other measurements. So you're not basically using your super expensive VNA that is just driving the extenders. You can be using it to do all the other measurements. So basically, this is resulting in a better utilization of your capital equipment. So just introducing one VFX into your lab can return your full VNA back to your lab to make other measurements. And like we have mentioned today, like I have mentioned today on the presentation, that the VFX is very cost effective. Now think about it like this. Let's say your VNA is $100,000 and you're just using this $100,000 instrument just to drive a couple of extenders, which means per station you're using $100,000 simply to drive the extenders. Since the VFX is priced at $25,000, now instead of just having one VNA, you can have up to 4 different stations that can drive your extenders, which means you can scale as well. So this is one of the most important operational advantages of the VFX. Some of the other operational benefits are, other than the architecture itself, the VFX was designed around practical day-to-day workflow improvements. So anyone who has dealt with using frequency extenders just know how, what are the challenges that come along with it. And some of these challenges are, reconnection of your IF and LO loops, connector wear and tear, operator error, because there's so many connections to do every time you have to configure your extenders, and the fact that it takes that long to configure the setup itself, so longer reconfiguration cycles. So now with the VFX, all of these issues are permanently eliminated, since you can have a system that is tied to the extenders permanently, so there is no reconfiguration. You don't have to switch between having the extenders connected to it versus not connected to it. So you can always have a system that remains tied to the VFX, and you can use that station whenever, which means there's less downtime. And then you have a system that's always ready, so ready to go, which means faster measurement turnaround. Now let's talk about the cost and scalability. Another advantage of VFX, or the most important advantage of VFX, is scalability. As I've mentioned, since the VFX is significantly lower cost compared to a full VNA, there's an opportunity for you to practically deploy multiple stations instead of just having one. And this becomes very, this is a great advantage and is ideal for environments that need production testing or validation labs, university, where people do not want to spend a lot of money just to have the extenders running, or multi-user facilities where the extenders are shared between multiple users, or you need to have multiple stations. So scalability is one of the biggest advantages of the VFX. Now, the ideal applications. Since the VFX itself is intentionally made application agnostic, any environment that requires your extenders to be running will benefit from this VFX. And most commonly, these applications are 5G FR development, satellite communication, automotive radar, imaging system, material characterization, phased array testing, and of course the production testing environment. So the bottom line of what we've discussed throughout up until now is VFX is definitely not a VNA. It's not trying to replace a traditional VNA. It is just basically trying to solve a reality in the millimeter wave test environment, which is basically where people are struggling to scale it, or they're struggling with reconfiguring the extenders back and forth, where sometimes the VNAs can break. So BFX is only trying to solve that problem, where it can just be your extender driver. And if you're that user that's basically only using your VNA to drive the extenders alone, BFX is the instrument that you should have been using all along. So BFX comes with advantages of lower cost, higher drive power, fewer points of failure because you don't have to, go back and forth with your reconfiguration. And of course, it's freeing up your VNA, which you could be using to make other valuable measurements. And with that, I would like to dive into the live demonstration. Let me go ahead and share my screen. And one important thing I did want to mention during my presentation is, although I'm using Aravant extenders, because this is the extenders that we have right now and was free for me to use for this webinar, we have tested VDI all the way up to 1 terahertz. With the BFX system. So it's not just Aravant that works with it. Any extender system that is coming from other vendors can definitely most likely work with BFX. And VDI, we've tested up to 330, then we've tested 500 to 750, and we've also tested 750 to 1.08 to be specific terahertz. So the BFX works all the way up to 1.08 terahertz, if you're wondering what's the maximum frequency. And I also wanted to mention that the BFX base frequency itself is 4 gigahertz to 20 gigahertz. So this is basically your frequency that your extenders will be using just to drive. And of course, then you have your multipliers that will yield the final frequency range that you would intend to use. Why it starts at 4 gigahertz is simply because most of the frequency extenders out in the market don't really use LO or RF input frequency below that, which is why this starts at 4 gigahertz, and you don't want to be paying for the frequency that you would never be using. So, which is why the BFX was designed to start at 4 and all the way up to 20. And that's, again, I want to highlight, that's just your input frequency. That's not the frequency that we're talking in terms of extenders. With the extenders, you can work all the way up to 1.08 terahertz. I hope you are able to see my software screen. And this is just your regular S2 VNA software. Most of you should be very familiar with our S2 VNA software, which is basically used to drive all our full 2-port VNAs. So since the BFX is a 2-port unit, it's using the same S2 VNA software here. Software-wise, there's really no change. There's nothing different. Time domain is still there, and if anybody wants to make converter measurements, you still have those features. You have time domain gating. All of those features are, still there. Nothing is taken off. BFX is just simply being added onto, what the software already has. So it's just another instrument that the software is supporting. Like I mentioned, I have a 50 to 75 gigahertz extender here. And since I'm using the one from Aravant, I went to the frequency extend mode and selected the model that I'm using. If you don't see the model that you intend to use, it's very easy. You don't have to think that it doesn't support it. You have to just simply click on the custom menu, enter the start, stop, and the respective multiplier values that you have for RF and LO and the power levels, and simply click on apply. For VDI, that's how you would be using the custom menu to enter your frequencies and the multiplier value to run the extenders. So I have all of that configured, and like I said, I did a full 2-port calibration using the WR15 Cal Kit. And I simply have a filter connected. What I did want to show with this measurement is I am going to load the touchstone file that I have, which was measured using our C4220 VNA and this same extender. So I'm just going to push that to memory. Right now I have the measurements running from the BFX itself, but just to show the comparison between what I have with the C4220 and the BFX, just to see how close or not close they are, I wanted to show. So right now there's 2 different traces. It's hard to tell because the measurement is so spot on between the C4220 and the BFX. It's really hard to tell, but there is a memory trace, as you can see. Maybe I can just zoom in. a little more. Yeah, as you can see here, there is a memory trace and I've super zoomed it and it's at 0.1 dB per division, which is why you couldn't tell when the scale was like at 10. So there is a memory trace. As you can see here, there's two different traces, but it's so close. And of course, this variation in the subtle difference can definitely be from the user calibration and not because of the instrument itself. So I just wanted to show the actual live measurement versus what we've measured in the past for the same filter and for the same frequency extenders, but with a VNA. So if there's anything in particular that you guys would like to see with the software itself, please let me know and I can definitely go over that information. But I thought it would just be nice to see the difference between the two measurements between two different setups. So that was my idea behind importing that touchstone file. So I'm pretty much done with the demo itself. Unless you guys want me to show us something specific in the software, please let me know. And if you have any questions, go for it. Hi, Rahul. Yes, you can go ahead with whatever question you have.
Hi, thanks for the demonstration. So
Yeah.
you mentioned that your system can go all the way till 1.08 terahertz,
Yeah.
right? Would you be able to give me some demo or some insights in that? Because I'm a bit interested on up to 1.5 terahertz, but it is fine if it is 1 terahertz as well.
Okay.
I'm mainly interested in terms of what kind of power level you are able to deliver from your input side or TX side, I would say.
Yeah.
And how would that compare with because there are other competitors as well, like Toptica, and which they also have terahertz, but they are based on optical setup.
Okay. Yeah, so I believe the
yeah.
VDI extenders that we have for the 1 terahertz, I think the input requirement was 10 dBm for both RF and LO. Now let me quickly turn off these extenders because I don't want to input high frequency, high power into these because they don't need as much power. So you can just play with your RF and LO power here. And the VDI extenders input power requirement, I believe, as I remember as clearly as I can, is 10 dBm for RF and LO for 1 terahertz. So you can change this accordingly. Now, again, this depends on the cables that you're using and what loss this has. And usually for the ones that I'm using here, the loss is around like 1 or 2 dB for, this is like a 4-foot cable. So you have to consider that into account as well. Like you can just have your RF and LO power level. Let's say you can start with 11 or 10 even. And then what I recommend doing is you disconnect the RF and LO cables before you connect it to the extenders. Take a power sensor, measure what the power level is showing. And then how we basically deal with the power level is, let me turn this back on. So for this, I just need RF of 0 and LO of 2 dBm. And if you want to be very, very precise to see what's going into it, like I said, use a power sensor, see what the power is at the end of the cable, and then connect it to the extenders. And then you have to look at the receivers. Right now I have the filter connected, but you look at the receivers with the short connected between the extenders. And then you kind of play with the power levels just to get like a pretty flat response as much as you can with the extenders. That's when you know that the power levels are working pretty well. So that's how you go about it. And for the 1 terahertz, it was 10 dBm. So you can definitely adjust that power level with the software.
Is it possible that you can show me one free space measurement of 1 terahertz?
Right now we don't have the extenders with us.
Okay.
VDI shipped it to us because when we initially came up with BFX, we wanted to see how far we can go with the frequency itself, because previously our 20 gigahertz VNA could only go up to 330 gigahertz with VDI. And with BFX, we wanted to see if we can go beyond that, and we were able to. But what I can definitely do is we are coming up with a report that we're trying to do with the 1 terahertz because we finished evaluating that. So we're trying to put all these frequencies as in a report. So we would be able to share that. Would that work for you?
Yeah, besides report, it'll be good if we can have a separate meeting and you can give me a demonstration because then I can take from there to our internal discussion.
Yeah. Okay,
my
let's do
team.
one thing. Let me discuss this with my team because right now I don't have the 1 terahertz with me for like right now webinar, but I can see if it's still in the building or did we already ship it out because we recently wrapped up. It was this week when we wrapped up the whole testing. So if it's still in the building, I can definitely ask them to hold on to it for a couple of days. And then maybe we can come up with a time frame for when it works and then schedule a call.
Yeah, and would be great if in the meantime you can send me a couple of measurement numbers and reports that how does that looks like.
Yeah,
then I can
we
already
can,
start.
yes, we can do
looking
dynamic
into it.
range, we can give you all those basic, measurement reports. Yep, we can do that.
Because recently we did measurements from up to 1.2 terahertz, but then yeah, using optical systems.
Yes.
And then there the power limitation is a challenge
Okay.
itself. So
Okay.
yeah, I'm quite interested that what is the free space measurement if it is just air, because if you have your 2 TX and RX and we have some distance.
Yeah.
And in the free space, you should be seeing already the absorption by the water molecules in the 0.1 to 1 terahertz. So around 500 or 700, you should be seeing those default absorption peaks. If those things are visible in your default free space measurement, then I'm very happy already to take into
So when
consideration.
you're talking about free space, do you just want me to have the extenders connected pointing at each other, but with just some distance between the two
some
extender
distance.
heads?
Yeah, some
Yeah,
distance.
okay. All right,
it
so
should
you
have
just
those
basically want to
peaks.
see what the S21 looks like and what the signal it's picking up.
Yeah.
Okay, all right. So yes,
Okay,
I will
thanks.
definitely get back to you on that and we can work a time to see when we can schedule that and do that.
Okay, yeah, thanks.
Yep, no problem.
Any other questions?
Just a question from my side, Prakruti. The software you showed us, this is the same setup like for the existing VNA models, right? So it's also free of charge downloadable from your website, right?
Yes.
Yeah.
Yes, the same as to VNA software. Since BFX is a 2-port, it makes more sense to add it on the S2 VNA software. It's just the same software. It's free to download, no licensing or anything.
Yeah. Maybe a general question to everyone. Does everyone have, for the moment or the next coming weeks or months, a project where this solution can be useful for your application? Just an open question, huh?
No, not me.
Yeah, I need this for gas sensing application.
We don't need it for, in short term, but we are still interested in the long term. So yeah, it was nice to see a live demo also. Thank you. Yeah.
Yeah. Thank you. Now that we have Prakruti here, maybe there are some questions about standard VNAs from copper mounted technologies, not only for this new BFX, but maybe there are some questions from your side for standard VNAs. So I would say now it's the right moment to ask Prakruti.
I have. Pretty soon we're moving up to test up to 15 gigs. So we would be interested in seeing if there's something that goes from really low, I don't know, maybe 100K all the way up to 50 gigs.
50?
Yeah, 50, yes.
Okay. Right now, you guys know, we discontinued the 5243, so we don't have a VNA that goes as high as that. But we do have the new A2202 VNA that goes up to 22. And if you want it all the way to 50, what we're recommending customers is using the L1 extenders that goes from 20 to 55. So that way the whole band is covered from low frequency up to 22 and then 22 to 50 gigahertz.
Okay. And those extenders will be coax or?
Those would be, I'm sorry, I didn't get that.
The extenders, the connectors,
Yeah.
they will be 2.4 gig, 2.4.
Oh yeah, that's MMT 2.
Yes.
I believe it is, yes, 2.4 or 1.85.
Yes,
Yeah.
okay.
Yeah.
Great. Okay, something to check out.
Yeah.
Oh, thank you very much. Yes.
Yeah, of course.
We'll make our research because at the moment we don't know when this will happen, but it will be in the future. So
Okay.
we have something else to look at.
Yeah.
Thank you.
Of course. Even if you guys are not able to think of something at the moment about the whole webinar that we discussed about, feel free to send an email whenever you have a question. That's totally fine, and then I can always get back.
Great, thank you.
Yeah.
Prakruti, can we send the presentation you just showed us? Can we send them to the customers here?
Yeah, absolutely.
To the attendees?
Yeah.
Yeah.
Absolutely.
Okay, great.
Yeah.
I think it's useful for them, huh? So, all right. Any more questions? No?
No, I'm good. Thank you.
Okay, thank you. Then, Tara, you will share the video, or what is your plan?
Yes, I will share the presentation in the video, indeed, both of it. You will receive it in your mailbox today or tomorrow latest. So thank you for joining, and hopefully you learned from this webinar. And Erik will contact you in the future if there are any possibilities within this concept.
Yeah. All right. Thank you all for your participation. Also, Copper Mountain Technologies, thank you very much for the presentation, and we keep in touch. Yeah.
Yeah, of course. Thank you.
Thank you very much.
Before,
We also
I
thank
leave-
you.
I'm so sorry. Before I leave, I just wanted Rahul to leave his email in the chat so that I can get back to you with the 1 terahertz VDI question.
Yes. I think we had one demonstration in the past as well.
With the 1 terahertz?
No, not for 1 terahertz. I was looking for portable VNA options for our on-field application in greenhouse, but
Okay. Oh yes, I do remember that. Okay.
yes.
All right. I will work with the timeline and see if we have that extender available, and if it's available, maybe we should be able to do it tomorrow or on Monday if that works for you. But I'll work with you on the time frame. Yeah.
Tomorrow I'm in office. Yes.
Okay.
So if it is possible, then I can bring my colleague as well.
Okay. Yes, I will let you know like before the end of the day today, US time. Yep.
Okay. Thanks.
Yeah. All right. Thank you, everyone.
All right. Thank you, everyone.
Thank you very much.
Yeah,
Thank
you.
you. Bye-bye.
Thank you for your time.
Bye.
Thank you. Bye-bye.